Okay, so let's go to the chapter 1. Chapter 1 is the introduction of the MATLAB. So you learn some basic operation in MATLAB. So for MATLAB actually is not free for students. Okay. But we can use the online free MATLAB. For this one, so go to the Canvas, log in Canvas, and go to the course, EGN 205. Then go to announcement. Then go here, online MATLAB, and OK. So first, let's talk about a little bit about Octave. Octave is open source software, so it's similar to MATLAB, but it's actually is not MATLAB. You can do most MATLAB code in Octave, okay. But the better you use online MATLAB. So online MATLAB is free for 1 month for college students. So just click this link. So matlab.mathworks.com. Then click sign in. If it's your first time and go to this place, then you need to create an account. So click create account. Then type in your BCCC email address. Okay. Here, the better use the BCCC email address. So that's the your ID at student.bccc.edu. Then click last. Then you will get an account. Create account. After you get an account, then go back there. So now I can sign in. Just type in my email address. So BCC email address. Then password. So for online MATLAB, just click here. So online MATLAB again is free for 1 month for students, for college students. But when this license, online license is expired, you can still subscribe to it again for another 1 month. So you can use this online MATLAB month by month free. Okay, so this is the online MATLAB. This is the first choice. Okay, so go back to our handout. So for MATLAB, when you define variables in MATLAB, so MATLAB is case sensitive. So this means these two, first double arrow here is the proper symbol, okay, proper sign. So you can see here, this is the proper sign. So you can type command after this. So this is the command window. So you can type any command, MATLAB command or functions key. Okay. So this is the toolbar, and this is the folder, okay. And this is the workspace. So this will show the variables here. Okay, so here I defined the two variables, register A, capital R, capital A, and another one is the register A, but now it's the small r. So actually, so there are two different variables. So we can check in MATLAB. So first one, that's okay. So this one, because I didn't, okay, so I can do this. So this one, so maybe equals 2. So you can see small r register A value is 8. Then another one, so that's this one. So capital R register A 3. So you can see now there are two different variables in workspace, and each variable has the different value. Okay. So again, the MATLAB is case sensitive when you define variables. So you can just think about this. Okay. In MATLAB, so there are several commands here. First one, name, length, maximum. Name, length, so proper, so you can just use the tab key to finish this. Okay. So 63. So this means the maximum length of a variable name is 63 characters. So 63 characters. And also, when we type a lot of commands in command window, we can use clear command to clean the variables in the workspace. Okay, and also use CLC to clean the command window. Another useful command is VER. VER is for version, just shows the MATLAB version and also the toolbox installed in this MATLAB. If you need more information, so you can type version this command. Okay, so this give you, oh no, this one is just very simple, information of MATLAB. So just the version. Okay, so CLC again. So now we can keep going in handout. So for chapter 1, actually you will learn chapter 1 in first several weeks, maybe 3 or 4 weeks to finish the chapter 1. Okay. And for the variable, so you need a star with a letter followed by letters, digits, or underscore. So no symbols. Okay, no specific symbols here. Semicolon. So semicolon, this means is for hiding the result in the command window. Okay, so we can use this as example. So now this shows the result A equals 3 in the command window, and also variable is shown in the workspace window. Then another one. Okay, so now we have the semicolon at the end. So now you can see show nothing. Okay, but this variable is already in the workspace. So B equals 4. For this one, so when we write the MATLAB code, usually we use the semicolon at the end for hiding the results in command window. Percent, so this is comments. Okay. CLC, I showed it before, this clears the command window. CLF clear the graphic window, so we will use this later. Clear, so remove all variables of the data from the workspace. So let's do this again. Clear, so nothing in the workspace. CLC, clean the command window. Ctrl C, start a program. So this is just in case if we write a wrong code and the code just keep running and cannot stop. So we can use the Ctrl C. Just press Ctrl key and hold Ctrl key, then press the C key. Stop the program. Save, so save the data or variables in the workspace. So you can save to a file. Okay. quick or exist. So this one is terminate the MATLAB. So we can try this. If you type here in command window, so you can see MATLAB is quit. So enter again. Okay, computer. So this is show the information about the computer net on which MATLAB software is run. So we can check here. Since this, or even this is online one, so check this. So this is the Linux. So AN is usually for Linux. A for the AMD 64. So this is the 64-bit operating system. G actually version showed before, just show the MATLAB version number. Where so display the version number for MATLAB and also the all toolbox installed in MATLAB. Who lists the variables currently in workspace? Whose is the current variables and their size and the type. Okay, so we can do this. Okay, nice. Maybe simple one. A equals 3, B equals 4.5. Okay, I use the semicolon, so these two results are not showing the command window. So who? So now we have the two variables A, or sorry, 3, A, ANS, B. ANS, this is the for this one. So this is a temporary result. Then whose, this give you the detailed information of the variables. So A, 1 by 1. So this is in MATLAB. All variables is a matrix. Okay, so it's a matrix. So since this variable A is just a number, so this is a 1 by 1 matrix. And the bytes, so just use the 8 bytes. So this is for the integer number or whole number. So in the double size. Okay. Computer, so this is 1 by 7 matrix. So this is actually this is a row vector. Okay, so 14 bytes. Yeah, correct. Help, so you can use the help and then following by a function name or command name, so you can get the information of that function or the command. Format, so this is show how to show the variables or results in the command window. Format rules, so this is the default format. Format compact, so let's use this one for saving space in command window. So now let's clean this first. Also CLC. Okay, paste here. Format compact. So now let's clear everything first. So A equals 3, B equals 3. So compact, so just for saving space between the commands. Okay. Now we can go back to the rules. So just check difference. So C equals 5. D equals 4. Seems no difference here, but if you use the MATLAB in computer, so this will be clear. Okay. Then this one short or long, this show the how many digits after the decimal point. Okay. Just for example, A equals 1 divided by 3. So we know this is 0.333. Oh, now this is the loose. Okay, go back, compact. So then we use the format long b equals 2 divided by 7. So you can see now there are more digits after the decimal point are shown. Okay. So usually short is enough. Okay. Okay. So see you again. So for MATLAB, there are two type files, M file. So M file station is the M. So this is a text file or script file. Okay, so that's you write your code. Data file, so .mat. So this is for you can save the variables in this file. So this is the data file. So again, so MATLAB variables is a matrix. So basic data structure is a matrix. So it's could be a number, could be a vector, row vector, or column vector. So just like this. I said before, if a number, so it's the 1 by 1 matrix. Now this is a 3 by 3 matrix. The matrix name is the A, okay, capital A. So for matrix, usually we use the capital letters or uppercase letters. Okay. So 3 by 3. If you want to type this matrix in, so you need to use this word. Okay. So let me type here. So A equals, don't forget this one, square brackets. Let me double check here, square brackets. So left square brackets. So 1 space 2 space 3. So this is the first row. Then use the semicolon separates row by row. Okay. Then space 4 5 5 3 semicolon again 7 8 9. Then close brackets. So now you can see this is the 3 by 3 matrix. So capital A value size is 3 by 3. We said before, the one number is used 2 bytes, right? Now 3 by 3 total 9 elements in this matrix. So should use the 18 bytes. Let me check. Oh, no. So 3 by 3, so is the, one is the 8, okay. So 8 times 9, so 72. 75, yeah. Okay, so this is the original matrix A. From the matrix A, so we can get a number that assigned to another matrix. So here, let me show this again. So A first, then B equals A 2, comma 3. So 2, comma 3. So this means we need to get an element from the row 2, then column 3. Okay, I think I forgot to mention this. So for the row number, so from the top to the bottom. So row 1, row 2, row 3. Column number from left to the right. So column 1, column 2, column 3. So B equals A 2, comma 3. So now it's from the column from row 2 to first, then column 3. So it will be 6. B equals 6. So for the A here, so the first number is the row number. The second number is the column number. So now we can use another one, B1, maybe A1, 2. Okay, so this from the row 1, column 2. So it's the 2 here. B1 is 2. So B1 is 1 by 1. B is also 1 by 1. Yeah. So column, so this means use all the lines in this. So first number is column, so this means we will get all rows in column 1. So C equals column, comma, 1. So this will get the column 1 from the matrix A. So 1, 4, 7. Something wrong. Yeah, right. Oh, sorry, my fault. Okay, so C equals A. Okay, A first. C equals A column, comma, 1. So this will get from the column 1 in matrix A. So 1, 4, 7. So for the C, so you can see C is 3 by 1. So 3 rows, just 1 column. Okay, so 3 by 1, so this is the column. Similarly, so you can see we have capital C and small c, capital B, small. So again, case sensitive. So that's C1. Similarly, we can get a row vector. So maybe 2 to 3. So this is the row 3. So 7, 8, 9. So C1, 1 by 3. So this is a row vector. Okay, I did this. Then this one, so E equals A column current 2 to 3. 2 to 3. So this means we will get the elements from the column 2 to the column 3. Column 2 to column 3. So E, so is the 2 by 3. So you can see here. Oh, so 3 by 2. 3 rows, 2 column. Okay. So column 2 to 3. All elements in the rows. So this one. Okay, so of course the space is limited here. Let's clear first. Again. So similarly, let's use F. So equals A. So we can use the 2, 2, 3 in row number. So this means row 1 from the row 2 to row 3. And the column number, I use the 1, 2, 2. So row 2 to 3. Column number 1, 2, 2. So it should be 4, 5, 7, 8. So 4, 5, 7, 8. So it's 2 by 2. Yeah. Okay, so you can define variables. Now we just use the numbers. We can also use the characters. So here, let's clean first. Also, CLC. And for command, you can use the arrow key, up arrow key, or low, down arrow key, get the command from the list. Let's see here. So first equals down. So this is the first thing. Down. Let's copy J. Then last name Smith. Then you can get the full name equals, so square brackets again. So first space last. So name equals square brackets first. So this is the variable we used. Then space, one space between first name and last name. So we can use this variable direct. So name equals John Smith. Okay, so this is some the mathematic or arithmetic operator in MATLAB. So plus, minus, multiplication, division, and the power. So you can use the decimal number here. So 1.1 plus 2.2, 2.2 minus 1.05, 3.3 times 4.5, like this, 4.4, actually I did 34 divided by 6.78. So you can use MATLAB just like a calculator. Okay. So yeah, you need to just type all of these things in MATLAB. Try to know the MATLAB. Then this is the power. Okay. 2.41 power to 3. This number you can check. 2 power to 3, we know is 8. Okay, so this is how to show a number in scientific format. So you can use this way. So divide it. So type this. Okay. So 1.37 times 10 power to the 3. So we know this is 1,370. In MATLAB, usually we use this method. Okay. So 1.37 small e, then positive for part number 3. So this is the same one. So you can see for part number, you can also ignore the plus symbol. Okay. So get this again. So delete plus. So you get the same number. This one. This is for the negative power number. So 5.8 e minus 9. So this one is very small number. This is some the special values in MATLAB. Pi for pi. So 3.1416 actually, so we can use format more, show more digits. So 3.1415926535897993. Go back to the shift. Okay. I or J, so this is the image root. Okay, this one, so it's square root of the -1. INF for infinity. EPS, so this is the smallest number in MATLAB. In MATLAB, so we also have a lot of the mathematic functions. EXP for exponential, log, log 10, so base is 10, log 2, base is 2, log, this is base is the national number, national constant, so we know the SQRT, square root, ABS for absolute number, sine, cosine, tan, cotangent. So this is some example here. So let's go back to log first. So show more digits. EXP1. So this will show the natural constant 2.718 something. So we can use the help to get this function information. So help explanation. So EXPX, so you can use X as an argument of the EXP. It's the exponential of the elements of the X. E to X, okay. Log 2, okay. So log 2, this number, we will use the log EXP1. So EXP1, so we know we get like the natural constant. Log, the base is the natural constant. So it's 1. Then we get 1, log 2, 2, so it's also 1. Log 10, 2. Then square 2. Square root of the 2, 1.44142. Then ABS, absolute. So minus select numbers, any negative number here, so you get a positive corresponding. So then sine, cosine, pi, I said before, pi is for pi. Then for the sine here, the argument or the input is not the degree. Okay. So half pi, so we know is the 90 degree, right? So this is 1. Then if pi over 3, pi is the 180 degree, okay. Then pi over 3, this is the 60 degree, so maybe it was 6. 6, pi over 6, then it's 30 degrees, so we know it's 0.5. Then for the cosine, so we know the cosine 60 degrees, so it's the 0.5. Then we can also use the negative. So minus, so this is also positive 0.5. Then time. Pi over 4. So this is 45 degrees, so it's 1. So we can also use half time for getting information. Time of the arguments in radians. Okay, so this is all these functions arguments are ingredients, not needed. COT quotient, so it's the same one. So this is some the round functions. Okay, fix rounds number of the argument toward 0. Floor rounds toward to negative infinity, so go down. Cell rounds toward positive infinity, so go up. Round, so rounds toward nearest integer number. Mod, modulus, REM, remainder after division, sign, signal function. Okay, so we can try this one. So fix 1.5. So 1.2 fix toward to 0. So should go to 1. This is the one. Then another one minus 3.2 minus 3.9. So this one toward to 0, so should get to the minus 3. Okay. Floor 2.9. This is go down, so you go to the negative infinity, so should get 2. Floor next number minus 2.9. Go to the negative infinity, so minus 3. Cell 2.1. Go up to the positive infinity, so 3. Okay. Then cell, I think a negative number, minus 2.9, positive infinity, so minus 2. Round 4.6, so round 4.6, the closest integer, so should be 5. We can try another one, round 4.2, 4.3, so we know should go to 4. Then negative one, so round minus 4.6, closest one, so should be minus 5. Mod, so get modulus. So mod 12 divided by 3, so divided by 5. So modulus we know is the 2. Okay. So we can try this again. So 14. So it's 4. No. We can have mod modulus after division. Okay, so this is the remainder. So REM 11 by 3. So 2. Remainder is 2. Okay, so this is the negative one, negative number, so you can try it yourself. Then the last one is sine function. Sine function, so it's very special one, and I can have this first. So signal function. So signal function actually so returns 1 if the element is greater than 0. 0 if the argument equals to 0. And minus 1 if the argument is less than 0. So we know now if sine 2.1, so it's the 1. Sine minus 2.1, so it's minus 1. Sine 0, so it's 0. Okay, so that's for week